Hi class, Assalamualaikum and hi everybody. In our consultation hour session, I'm going to discuss with you several questions from topic 3, momentum and impulse. Let's start with question number 2. A 50-gram ball is dropped. Hit the floor with the speed 25 meter per second and bounce off vertically with speed 10 meter per second. If the time of impact is 5 milliseconds, calculate the average impact force. From the question, given that mass of the ball M is 50 gram and we have the initial velocity or initial speed for the ball is 25 meter per second. This is U. And the final speed for the ball is 10 meter per second. So this is the V. And given the time of impact T 5 milliseconds. And you need to calculate the average impact force. So for this question, you need to find out what is the force F. Okay, from the given situation, we can come out with a diagram. Okay, so here I have the floor. Okay, we are going to drop a ball, okay, with the initial speed, okay, before it reach the floor is 25 meter per second. So here I will consider that my initial speed is in the negative direction because it moved downward. So you need to put negative here. Okay, when the ball reach the floor, it will bounce back. Okay, with the speed of 10 meter per second. For the final speed here, I will take it as a positive value because the ball here will move upward. Okay, so we have the time of impact is T 5 millisecond. So you need to convert it to 5 times 10 power of negative 3 second because we know that milli is in the value of 10 negative 3. Okay, so the first step, we are going to find out what is the impulse. Okay, impulse is equals to the change of momentum. So from the equation, you can write it as mv minus mu. Okay, from the equation here, you can factorize it. So it will become m in the bracket of v minus u. So now we are going to substitute the value of m, which is 50 gram, and you need to convert it into the SI unit. So, you akan dapat 50 times 10 power of negative 3. Okay, so V minus U, you are going to substitute the V as a 10, positive 10 meter per second. So, minus here, you are going to put it as a minus. Okay, and U just now, the value of U is negative 25 meter per second. Okay, so next, you are going to calculate the value of the impulse. Okay, so you are going to get impulse equals to the 1.75 kg meter per second. Okay, next step. After you get the impulse, okay, we know that impulse also equals to the F dt. Okay, so just now you have calculated the value of the impulse, substitute it as 1.75 and we want to find what is the average force. So here the F here is referred to the average force. Okay, the time of impact, okay, substitute it as 5 times 10 power of negative 3. Therefore, you will get that the average force is 350 Newton. Let's continue our discussion with question number 3. Figure 3.1 shows an approximate plot of force magnitude F against time t during the collision of a ball with a wall. Based on the graph, determine the impulse. So we need to find out what is the value of the impulse. Okay, from the FT graph, okay, where the force is in Newton and T is in second, okay, you have the shape of a trapezium. To find the impulse, you need to calculate what is the area under the FT graph, where you need to calculate the area of the trapezium. Okay, from the graph, we can get the value of force. Okay, the average force is 100 Newton and the time interval is between 0 to 6 seconds. Okay, so to get the impulse, J, this is equals to the area under the FT graph. So you are going to get the area of trapezium. So we need to apply the formula of an area for the trapezium. So here I will get half in the bracket of 6 plus 2 times 100. Okay, so you are going to get the impulse is 400 Newton second or in the unit of kilogram meter per second. Now, let's discuss question number 5. An object P of mass 8 kg moving at 5 meter per second collides with a second object Q of mass 6 kg moving at 4 meter per second in the opposite direction. After collision, object P moves in opposite direction at 1 meter per second. Question A. Determine the magnitude of velocity of object Q after the collision. And B. State whether the collision is elastic or inelastic. Okay, so from the question given, I will come up with a diagram. Okay, to show what happened before collision and what happened after the collision. Okay, we start with the before collision. Okay, I have the object P with the mass 8 kg and it will move to the right. Okay, with the initial velocity is 5 meter per second. So when it moves to the right, I will consider that the value of 5 here is a positive because it's moved to the right. Okay, meanwhile, this is my object Q with the mass 6 kg and my object Q will moving in the opposite direction. Okay, so I have my UQ is 4 meter per second and you need to put it as a negative because it moves in the opposite direction, which is to the left. Okay, this is what happened before collision. Okay, now object P and object Q will collide. Okay, what happened after collision? Okay, we know that object P will move in the opposite direction, which is with the velocity is 1 meter per second and you need to put negative here. Okay, because now object P is moved in the opposite direction, which is to the left. Okay, so this is the object Q and we need to find out what is the magnitude of the velocity for the object Q. Okay, so this is what happened after the collision. Okay, to answer question A, we need to apply the principle of conservation of linear momentum. Okay, from the principle of conservation of linear momentum, it states that our total initial momentum is equal to the total final momentum. So for my initial momentum, I need to consider the momentum for the object P and the momentum for the object Q. So I will get MPUP plus MQUQ. And for the final momentum, I need to consider the momentum for the object P and for the object Q. So I will get MPVP plus MQVQ. So you need to write down the concept and also the formula. Okay, next step, we are going to substitute the value of the MP, which is 8. The value of UP is 5. So value for the P is a positive because object P will move to the right. And MQ is 6. UQ, you need to substitute it as -4. Why -4? Because it moves in the opposite direction. Okay, so MP again, substitute is as 8, VP is -1. Why -1? Because you get that direction of object P is in a opposite direction. So you need to put the negative here. Okay, MQ is 6 and you need to find out what is the VQ. So you are going to get from the calculation, VQ is 4 meter per second. And the question asks you to find the magnitude. Okay, therefore, the magnitude for the velocity for object Q, you are going to get 4 meter per second. Okay, so we are going to know that the object Q here will move to the right. Therefore, in the diagram, okay, actually you can label the direction for the object Q, where it will move to the right. For question B, you need to show that whether the collision is elastic or inelastic. Okay, to show whether the collision is elastic or inelastic, actually we need to calculate the total of kinetic energy, okay, initial and final. Okay, so here I will start by calculating the total kinetic energy initial. Okay, this one is the total kinetic for the object P and Q before it collide. Okay, so you will get that total initial of the kinetic energy. Okay, we have the kinetic energy initial for object P plus with the kinetic energy initial for object Q. Okay, we know that kinetic energy, the equation is K equals to the half mv squared. So this is a general equation. So we need to apply the equation here for the initial situation. So you are going to get half mpup squared plus half mquuq squared. Okay, we are going to substitute all the value given inside the question. So you are going to get the total initial for the kinetic energy is 148 joule. Okay, next we are going to calculate the final kinetic energy for the system. So you will get that final kinetic energy for object P plus with the final kinetic energy for object Q. Again, we are going to apply the formula for the kinetic energy, which is half mPVP squared plus half mQVQ squared. Okay, so please substitute all the value given inside the equation. Therefore, you are going to get the final kinetic energy is 52 joule. Okay, from the value of the total kinetic energy initial and the total kinetic energy final, okay, you can see that, okay, the value of total kinetic energy initial is 148 joule. Meanwhile, for the total kinetic energy final, you get the value is 52 joule. So we can say that our total kinetic energy initial is not equal with the total kinetic energy final. Therefore, you can state that the collision here is inelastic collision. So you need to calculate lah the kinetic energy before and after the collision to state, okay, the type of the collision. Okay, that's all for my sharing today. Thank you.